To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.
Hello my dear students, welcome to today's lesson. Today also I'm going to discuss with you all some more extra questions related to electronics. So even in the previous chapters we have been discussing some questions. So now extra question 11. Now you all can see there is a diagram given to us. So here first if we look at the diagram properly, you can see you're familiar with this. Once you see this arrangement where we have the 4 diodes arranged in a bridge manner. You all know it is a rectification bridge and that is used for full wave rectification where alternate current is converted to direct current. And since we don't have the capacitor attached anywhere, you all know it is without smoothing or only the rectification process, full wave rectify. So here, if you look at this symbol, you all know what is labeled as A is the alternating current source. Then the points X and Y are labeled. Then when we come to this part, you can see D1, D2, D3, D4. Those are all diodes connected in the correct manner. Then here you can see there is component Z. You all can identify that. What is it? It is a variable resistor. Then you can see points P and Q marked there. Not the points, actually they have shown the regions P and Q, maybe to identify the direction of current flow. You all know that. And here you can see component B, which has the symbol G. That means it's a galvanometer, a center zero galvanometer. It is useful to measure the current flowing through the conductor, and also you can identify the direction of the current flow. So that is component B. So we have identified all the components given there. Is that clear, students? So then we'll look at the question. So like I always tell you all, when you are given a question, when you are given a diagram, try to get as much as information as possible from the diagram given to you all. Then it's easy to answer the questions. A circuit used to rectify alternate current is given below. So the diagram is given to you all. Then if we look at the first question, identify the components A and B. What is A? Like I told you all, it is the alternating current source. Alternating current source. Or we can just write alternating current generator or alternating current source, I will say. So you all know there are 2 ways in which alternating current can be generated. We can use a bicycle dynamo or there is the alternating current generator. Either method can be used to get the alternating current. Then what is component B? You all can see it is a galvanometer. 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 Alternating current source is A and galvanometer B. Then the second question. Why is component B used in the circuit? Why do we use a galvanometer? To observe whether a current flows through the conductor and to observe the direction of the current flow. So here or we can say to measure or detect the flow of current and to observe the direction of current. Direction of current flow. So if we only need the magnitude of current, then we can just go for an ammeter. Ammeter shows the amount of current flowing or shows that there is a current flow, but it doesn't show the direction of the current flow. If you use a galvanometer, you can identify the direction as well. So you all know that. Then the third question. What are the forward bias diodes when current flows from X to Y in the circuit? Now, if current flows from X to Y, if we try to understand the direction, then current is going to go this way, X, then it will be through D1. D1 is forward biased, D4 is reverse biased. So, you can see that it has to go through D1. Then when it comes to this point, D2 is reverse biased. You all can see that. Current will flow this way through Z, that is the variable resistor, then from P towards Q through the galvanometer B. Then it will come back here, and when it reaches this point, again you all know D4 is reverse biased because D4 again joins with this point. So, it has to be through D3 and then back to point Y. So, X, D1, then Z, P towards Q through B, and then D3 and Y. So, in this, both D1 and D3, they are the forward biased diodes, whereas D2 and D4, they are reverse biased. I am sure you all can understand that. So, here to answer the last question, what are the forward bias diodes when current flows from X to Y in the circuit? Both D1 and D3. D1 and D3. Those are the forward bias diodes. Is that clear? So then we'll move on to the next part of the question. Part 4. What are the forward bias diodes when current flows from Y to X in the circuit? So it's in the opposite direction, from Y to X. So if we mark that direction, now, so from Y current flows, it reaches this point. Now here you can see D2 and D3. Obviously you can identify D3 is reverse biased. It doesn't allow current to go backwards that way. So it is reverse biased. So it is D2. Then D2, from there it comes to component Z, that is the variable resistor. Then from P towards Q through the galvanometer B, and then it comes through this, comes to this point. Again D4 and D3. You can see D3, although it allows current to flow this way, here there is the flow of current in this direction. So because of that, D3 is reverse biased. D3 doesn't allow current to flow. D4 is forward biased and allows current to flow this way. And when reaching this point, again current doesn't flow this way, current will flow towards X. So here you can see Y, D2, Z, galvanometer B, then D4 and X. So in this instance, both D2 and D4, they are forward biased. But D1 and D3, they are reverse biased here. So what are the forward bias diodes when current flows from Y to X in the circuit? You can say D2 and D4. D2 and D4. Then, what type of rectification occurs in the above circuit? What is the rectification? Is it half wave or full wave? I already mentioned this. It is a full wave rectification. Full wave rectification. Full wave rectification. Then the sixth part of the question. In what direction does the current flow through B, PQ or QP? Explain this briefly. Now, in both instances, we saw that current flows in the direction PQ through B. That is when the current is rectified. The alternate current becomes direct current. Then only the current can flow in the same direction. So, it is always from P to Q. You can remember that. So, current flows from P to Q. P to Q, PQ direction. Explain this briefly. The purpose of the circuit is to convert, we can say AC to DC. The direct current flows only in one direction. So, when it is full wave rectified current, it flows from P to Q. So, you all know there is fluctuation, but the direction does not change. The current or the voltage fluctuates between 0 and a maximum value. You can remember the graph, but still it is in the same direction. So, the current flows from P to Q. Is that clear, students? So, here we have answered the questions related to this particular circuit. So, I am sure you all can understand that. With that, I'll move on to the next slide. That is extra question 12. Diodes are used to rectify alternate current to direct current. So, that is what we discussed in the previous question also. And you all know if we use one diode, it is half wave rectified. If it is 4 diodes in a bridge circuit, rectifier bridge, then it is the full wave rectified. Then the first question. Write another function of a PN junction diode. What are the other functions of the PN junction diode? You can remember PN junction diode is used to protect electronic devices from being damaged due to incorrectly connected terminals. You all can remember that. So, because of that, normally there is a diode inside the power packs that supply electricity to different electrical or electronic appliances. So, that is another function. Then there is the PN junction diode that is used as the solar cell also. You can remember where there is a PN junction where light falls on it, and due to the light energy, there is an electromotive force generated, and that gives rise to generation of electricity. That is the function of a solar cell, and solar cells connected together in series and parallel gives rise to a solar panel. So, that is also another function of PN junction diodes. But here, write another function of a PN junction diode. I am going to write the protecting the electronic devices, that particular function. So, here to protect electronic devices from getting damaged by current supplied through incorrectly connected terminals. To protect electronic devices from getting damaged by current supplied through incorrectly connected terminals. So, that is the function. Then, the second part of the question, briefly explain how diode is used in the above. So, for that I will use the diagram. I have told you all students, always it's easier to use a diagram that gives more explanation. So, here we have a diode there. then the device so here that is the positive and negative terminal, and that is the device. So here normally current flows through the positive terminal into the device and it flows out through the negative terminal. Now that we have a diode here, this is going to be the direction of current flow. So that is how current will flow. Now if the terminals are connected in an incorrect manner, then what will happen? Current has to flow this way. But this particular diode here will prevent the flow of current because current has to go through the device and come out this way. That will not be allowed by the diode. So because of that, the device will be protected. So here we can say the diode is connected as shown in the diagram. Then it will not allow current to flow into the device if the terminals are incorrectly connected. So because diode allows current to flow only in one direction. So it will not allow the current to flow into the device if the terminals are connected incorrectly. So that is how we protect the devices. So the diode is connected as shown in the diagram, then it will not allow current to flow into the device if the terminals are incorrectly connected. If you want, you can also mention that is because diode allows the current to flow in towards one direction only. If you like, you can include that also. But that is the basic function of or the feature of a diode. That is how a diode works, PN junction. Only when it is forward biased, it allows current to flow through it. Or else we can show that here also. Diode allows current flow only in one direction. So because of that, it protects the device. Is that clear, student? So that is the complete answer how the devices are protected. Another function of a diode. So with that, I will move on to the next slide. So here we have extra question 30. First one, what is an LED? LED means light emitting diodes. So diodes that can emit light when functioning are known as light emitting diodes. So here you can say PN junctions that emit light when current flows through them are known as light emitting diodes. So you're familiar with light emitting diodes. Normally they are made of materials like gallium arsenide. So they are, when they function, when there is current flowing across the PN junction, there is light being emitted. It can be white light, red, green, blue, yellow, even UV, IR light. All those are emitted by different types of LEDs if they are made with different materials. And you all know the biasing voltage of LEDs is higher compared to the normal silicon PN junction. The minimum value is 1.8 volts. You can remember that as well. So, PN junctions that emit light when current flows through them are known as light emitting diodes. Then the next one. What are solar cells made of? What are they made up of? They are made of PN junctions. So, they are made of PN junctions or PN junction diodes. So, the third one, what is the type of electricity generated in solar cells? Now, you can remember students, solar cells provide electricity to the household. Although that is connected with the main national electricity grid, but the electricity that is generated is direct current. That is why we are able to use it in calculators, clocks and all those. There also you get the solar panels. Now, calculators you all know we either use the battery or the solar panel. So, from the battery it is direct current. Same way from the solar panel also we get direct current. So, what is the type of electricity generated in solar cells? It is direct current. Direct current. Or you can write it as DC also. Direct current. Is that clear, students? So, these are different types of diodes. If you have an LED, when current flows through the PN junction, there is light emitted. So, those types of diodes or PN junction diodes are known as LEDs, light emitting diodes. And even the solar cells are made up of PN junctions. And they generate direct current. So, with that, students, I'll move on to the next question. Extra question 14. The transistor, which is responsible for vast developments in electronics, is constructed using two PN junctions. You are familiar with that. Normally, we have one PN junction, then that is a diode. To that, if you add another P junction or an N junction, you get the transistors with two PN junctions. So, because of that only, we have two types of transistors. The PNP transistor and the NPN transistor. I am sure you all can remember that, students. So, the first question. Illustrate the structure of the two types of transistors using diagrams. So, we can use diagrams to illustrate the structures. We need to have two PN junctions. So, there should be two types. So, here if it is PN junction, to that if you add another P, then you get the PNP transistor. This is the PNP transistor. And here, if you have the PN junction, if you add another N region there, then you get the NPN transistor. Now, in this, you are supposed to show the types of transistors, but you all know since there are two PN junctions, there are three terminals because we have three semiconductor regions. And the regions at the two ends are emitter and collector. And what is in the middle is the base. You are familiar with that. So, this is going to be the emitter, then this will be the collector, and that will be the base. Same goes for this, emitter, base, and collector. Now you can change the emitter and collector. Sides can be changed. It doesn't matter. But when you have the standard symbol, you can easily identify the two terminals because always the arrowhead is indicated with the emitter and the other terminal will be the collector, and in the middle you get the base. So always base is in the middle. So this is how the arrangement is in transistors. We have the PNP transistor and the NPN transistor. So based on how the semiconductor regions are arranged. Is that clear, students? So then we will move on to the next question. Extra question 50. There are 3 terminals in a transistor. So we have already discussed that. Write the names of the terminals. So what are the names? Emitter, collector and base. You all know the symbols also. E for emitter, C for collector and B for base. And we usually use the capital letters there. Then the second one. Write the alphabets used to denote the above 3 terminals. So that is what I just mentioned. So emitter is E, then collector C and base B. Then third part of the question, write the functions of the 3 terminals. What are the functions? Now you all know emitter is the terminal that emits the charge carriers. If it is a PNP transistor, holes are the majority charge carriers that are emitted from the emitter. Whereas NPN transistor, the N region is going to be the emitter. So there it's going to be electrons that are emitted. So emitter emits the charge carriers, whereas collector receives those charge carriers. And base controls the amount of charges flowing from emitter to collector. Now that is like the control of a tap, how you open and close the tap. Less current flowing through the base, less current through the emitter collector circuit also. At the same time, if you increase the current flow, the charge flow through the base, accordingly the current or the charge flow from emitter to collector increases. The same way the current also increases, changes. So base controls the amount of charges flowing from emitter to collector. So those are the functions. If we write them here, emitter emits the charge carriers when the transistor is in operation. Collector receives, or you can say collects, the charge carriers when the transistor is in operation. And the base controls the amount of charge flow from emitter to collector. So that is the function of all the three terminals. Emitter emits the charge carriers when the transistor is in operation, and collector receives or collects the charge carriers when the transistor is in operation. And base controls the amount of charge flow from emitter to collector. That also when transistor is operating. So here we can see when the transistor is functioning. So by controlling the charge flow, it controls the current flow. Now I haven't mentioned the current flow here because you all know, students, if it is a PNP transistor, current flows from emitter to collector. But if it is an NPN transistor, current flows from collector to emitter through the base. So the direction of the current flow differs because of the P and N regions. So you are familiar with that. But always the charge carriers flow from emitter to collector. So depending on the type of charge carrier, the direction of current flow changes. I am sure you all can recall that. So with that, students, I'll move on to the next slide. Extra question 16. Draw the standard symbol of an NPN transistor. So the standard symbol, the basic structure is the same. Only difference is the direction of the arrowhead. That denotes whether it is an NPN transistor or a PNP transistor. I'm sure you all can remember that. So the standard symbol of an NPN transistor. We need to have the base there. Then the other two terminals here. Now here you all know this is base, collector, emitter. So at the emitter we have to show the arrowhead. In an NPN transistor, what is the direction of the current flow? Current flows outwards from the base, from here. Why is that? Because NPN, this region, emitter is the negative type semiconductor, N-type semiconductor. So the majority charge carriers are going to be electrons. When electrons flow from emitter base to collector, current flows from collector base to emitter. Therefore, the direction of the current flow is this way. I have told you all these, students. Without just memorizing the symbol, if you all understand what happens, it's more easier. So remember, this is an NPN transistor. So N means negatively charged electrons. Electrons are the charge carriers that flow from emitter base to collector. And conventional current flows in the opposite direction, positive to negative. So collector base to emitter. Arrowhead points outwards. Is that clear? So that is the standard symbol of an NPN transistor. Then the next one, draw the standard symbol of a PNP transistor. So that is the other type. Again here, like I told you all, the basic structure is the same. We have the base, the two terminals. Then base, emitter, collector. Then how do we indicate the direction of the current flow? Here it is PNP. P region means positive region. Charge carriers, majority charge carriers are holes. So when holes flow from emitter base to collector, the conventional current also flows from emitter base to collector. So the direction of the current flow is from emitter to base. Is that clear, students? So this is how we draw the standard symbol of a PNP transistor. You all know we can change the terminals. We can have the emitter there, collector here. So that way also it is accepted. If I draw that symbol as well, here we have, even for this one, we can draw that. So here base I will draw the lines and then so here how if you have the emitter there, what is the direction of the arrowhead? Again it is going to be from emitter to base. Here it will be base to emitter. So here base, collector, emitter. This is collector, base, emitter. So both the symbols are correct. In both, you can see there students, here the arrowhead points outwards, here also the arrowhead points outwards. So it is the direction of the arrowhead. So here in both, you can see in an NPN transistor, current flows from collector base to emitter, from base towards the outward direction. Whereas in a PNP transistor, current flows from emitter base to collector, or here emitter base to collector. So the arrowhead points inwards. So that is how you have to identify the symbol. It doesn't matter the direction, whether you have the collector up or the emitter up. It's always the emitter that has the arrowhead. You all have to remember that. So both are standard symbols. Here I have drawn both the symbols just for you all to remember and recall what we have learned. When you are answering the question, you can give one of the two symbols, either one of these two or one of these two. You don't have to draw both the symbols. Is that clear, students? So then, with that, I'll move on to the next slide. Extra question 17. Briefly explain how the transistors are forward biased. So first, I will explain for the PNP transistor, then I will explain for the NPN transistor. So again, if we draw the transistor, so here both the circuits need to be forward biased. Now here you can see if it is the PNP transistor, So PNP transistor, this is the emitter, base and collector. So current flows from emitter base to collector. In this, always you have to remember students, the base has to be forward biased with the same terminal. Now since this is a PNP transistor, this is the N region, base is the N region. So therefore, the negative terminal of the battery has to be connected to the base. Negative potential to the base. Negative potential, positive potential to the emitter because it is a PNP transistor. Then you can remember collector is supplied with the same potential, not the magnitude, the sign. If we supply negative potential to the base, collector is also supplied with the negative potential. So here it is negative potential, positive potential to the emitter. Positive, negative. So if it is a PNP transistor, emitter is connected to the positive terminal, collector is connected to the negative terminal. The same way, base is also connected to the negative terminal. So this junction, base emitter junction is forward biased, emitter collector junction is forward biased. But at the same time, the base collector junction will be reversed biased. That is the forward biasing of a transistor. And you can remember, we supply or we provide a small voltage for this base, while we supply a higher voltage for this particular circuit. Then there will be the collector current flowing, and here it is the base current flowing. Is that clear? So this is how we forward bias a PNP transistor. So briefly explain. In a PNP transistor, negative terminal of the battery is connected to the base. The collector is also supplied similar potential as the base. That is why the negative terminal of the battery is connected to the C terminal, while the positive terminal of the battery is connected to the emitter in a PNP transistor. So that is how we forward bias the PNP transistor. Then I will quickly read that also for you all, what I have explained in the diagram. In a PNP transistor, negative terminal of the battery is connected to the base. The collector is also supplied similar potential as the base. That is why the negative terminal of the battery is connected to the C terminal, that is the collector terminal, while the positive terminal of the battery is connected to the emitter in a PNP transistor. So that is how we forward bias. That is how we forward bias a PNP transistor. Then if we look at an NPN transistor. NPN transistor. NPN transistor, how do we connect that? So we have the transistor here. Now this is an NPN transistor. So how does the current flow? It flows in this direction. Here we have base, collector and emitter. So current flows from base to emitter. Now here this is an NPN transistor. So the base has to be supplied with positive potential. So we need to supply positive potential to base. So the emitter will be connected to the negative terminal of the battery. The same way, collector also should be supplied with the positive potential. So positive and negative there. Is that clear? So base is connected to positive terminal. The same way collector is also connected to the positive terminal. Emitter is connected to the negative terminal. So here also we supply a small potential difference voltage there and a higher voltage here. Is that clear? And in this, current flows from collector base to emitter. That is the collector current. Is that clear? So here, if we write the explanation, in a NPN transistor, the base is connected to the positive terminal of the battery. The same way, the collector is also connected to the positive terminal of the battery. The emitter is connected to the negative terminal of the battery. Is that clear, student? And a smaller voltage is supplied to the base while a higher voltage is supplied to the collector. So here you can say in both instances a small voltage is supplied to the base while a higher voltage is supplied to the emitter collector circuit. Is that clear, students? So that is how we forward bias a transistor. I have explained with both types of transistors. So here you understood this diagram if it is an NPN transistor. If it is an NPN transistor, current flows from collector base to emitter. So base has to be provided with positive potential. The same way collector is also provided with positive potential. Emitter is connected with the negative terminal of the battery. In both instances, it is connected to the negative terminal. And we supply a small potential difference here while we supply a greater potential difference there. Always base and collector are supplied with the same type of voltage. Positive potential, or in the other instance, if it is a PNP transistor, both have to be negative. Is that clear, students? So here, in a NPN transistor, the base is connected to the positive terminal of the battery. The same way, the collector is also connected to the positive terminal of the battery. The emitter is connected to the negative terminal of the battery. And here you can see in both instances, a small voltage is supplied to the base while a higher voltage is supplied to the emitter-collector circuit. You all know the reason. A small amount of charge carriers flow through the base, but depending on that current, there will be a higher current flowing through the collector-emitter circuit. Is that clear? So that is how we forward bias a transistor. With that, students, I will move on to the next slide. Extra question 18. A group of students arrange the following circuit using the transistor. In addition to the component shown in the diagram, they need to connect a microphone and a speaker to the circuit. So, if we look at the circuit here, you can have a look at the circuit, students. So, what do you all see? There are 2 points P and Q. Then you can see this component here, that is a capacitor. You all know the function of a capacitor. In this particular circuit, as you look at it, you all know this is a circuit to amplify the sound signal amplifier. So, you all can remember. We supply an audio frequency signal there, and the capacitor makes sure that the current that is flowing to the input circuit, that is the part A of the circuit, is going to be an alternating current. And then you all know here we will get an amplified signal. So, if we supply a sound signal, then you will get an amplified sound signal. Is that clear, students? So, this is the function of a transistor as a signal amplifier. So, then between P and Q, we supply the audio frequency signal, that is part A input circuit. Then here you can see X is the base, Y is the collector, and Z is the emitter. You can identify the transistors. And from the direction of the arrowhead, you all know it is an NPN transistor. Then here you can see between the base and the collector, there is a resistor connected there. A fixed value resistor, or you can have a variable resistor, a volume control, but you need to have a resistor there. Then from the emitter terminal, you can see emitter is supplied with the positive potential, whereas collector is supplied with the negative potential. And then you can see where is this RS points. Between 2 points R and S, there will be a speaker. Now they have mentioned there is going to be a microphone and a speaker. So microphone has to be connected between P and Q. Speaker will be connected between R and S. Is that clear, students? Then only this will function. Is that clear? So it is going to be the NPN transistor. So the emitter junction is connected to the negative terminal of the battery. Is that clear? So then only current will flow in this direction shown by the arrowhead. So that is the circuit. So you have identified the components, part A and part B. You all can see part A is the input circuit and part B is the output circuit. Is that clear, students? So then we will try to answer the questions. Write the names of the parts A and B of the circuit. Part A, input circuit. Part B, output circuit. A, input circuit, and B is the output circuit. Then the second question. What is the type of transistor used in the circuit? So, from the symbol of the transistor, you all know it is an NPN transistor. And also, students, you all can remember in our syllabus, we are using only NPN transistors. So, it is an NPN transistor. NPN transistor. With that, I'll move on to the next slide. So, here we have the third question. The same diagram is given to us. Identify the terminals of the transistor. So, there, identify the terminals. Now, here this is the symbol. You all know this particular, the vertical line with a horizontal line like that, that is the base. So, X is the base. then always the arrowhead indicates the emitter. Then the other terminal is the collector. So Y is the collector and arrowhead is at the Z terminal, so it is the emitter. Base, collector and emitter X, Y and Z. Is that okay? Then the fourth one, what is the function of T? T is a resistor. It controls the current flow through or in the base collector circuit, or to actually reverse bias the base collector circuit. So it controls the current flow through the base collector circuit. So usually to reverse bias the base collector circuit so that the current flow is limited there. There will be more current flow through this. That is how we use the resistor. Then the next part of the question, what were the students trying to illustrate using the circuit? What were they trying to illustrate? That transistor can be used as a signal amplifier. The transistor can be used as the signal amplifier. Then the sixth part. To which terminals of the amplifying circuit should the microphone be connected? Where do we connect the microphone? Microphone is to provide the audio frequency signal. Mic. So it has to be connected between P and Q. Points P and Q. Points P and Q. Between points R and S, you need to connect the loudspeaker. Then only you will hear the amplified sound. So then the next slide. What is the signal given to part A of the circuit? What is the signal? Audio frequency signal. AF signal, or you can say audio frequency signal. You can write it as AF signal or audio frequency signal. What type of current flows through part A? Part A, it should be alternate current. That is why we use the capacitor there. Alternate current. Alternate current, or you can just write it as AC. Alternate current. Then you can see to which points of the amplifying circuit should the loudspeaker be connected. To which points? Between R and S. You know that. That is the output circuit. Between R and S. Then the 10th question. What physical quantity connected with the signal given by the microphone is amplified by the amplifying circuit? Here they have asked what physical quantity connected with the signal given by the microphone. Physical quantity is going to be the amplitude. When the amplitude increases, you all know the loudness of the sound increases. So loudness is the characteristic of sound. Now here the signal amplitude will be amplified. That is why the name amplification. Amplification is increasing. So the physical quantity that is going to be amplified is the amplitude of the sound wave. So here it is going to be the amplitude of the audio frequency signal. So as a note, I will just write it here. When amplitude of a sound wave increases, the loudness of the sound increases. So that is why when you supply a small sound with less loudness, you hear a louder sound. You provide a soft sound, you hear a louder sound. So from that we understand the signal amplification process of a transistor. Is that clear, students? So here the physical quantity that is amplified is the amplitude of the audio frequency signal. Is that clear, students? So with that, I will move on to the next question. Extra question 19. Some components used in electronic appliances are given below. So if you look at the components, you can identify them. A, you can see it is a LED, light emitting diode. How do you identify that? This part of the head, the lens which gives out the light, then you can see the two terminals, the short terminal and the long terminal. Short terminal is the cathode, long terminal is the anode. Then in B, you can see the cylinder-like structure with three terminals, then you know it is a transistor. Then C, when you see these three lines there, you all can identify now these two, C and D, they look similar, cylindrical structures, but you can see here there are three lines. Here there is only one line at the end. So from that, you all know both resistor and diode, PN junction diode, look similar. But in a resistor, you get the color bands. Although they both have two terminals at the two ends, the resistor has color bands. So that is why we have three lines there. Whereas in D, you can see here, this is one line at one end. And also A and K, anode and cathode, are marked there. So that means D is a diode and C is a resistor, a fixed value resistor. That is how we identify the different components. So the first question, identify the components A to D. A is an LED, then B, transistor, C, resistor. It is a fixed value resistor. You can just write it as resistor, and D, diode. And here also you can write it as PN junction diode. Then the second question. In what direction does the current flow in component D? Illustrate using a diagram. So if you are to illustrate using a diagram, you all know current flows from anode to cathode. So here this is the part that is where you get the color band. So this is anode, this is cathode, and the direction of the current flow is this. Current flows in this direction from anode to cathode. Is that clear, students? So that is how the current flows. Here they haven't told us to use the standard symbol, because you all know if we use the standard symbol, then of course it will be like this. This is the anode, that is the cathode. The direction of the current flow will be this way, from anode to cathode, that is using the standard symbol. But here they have just said illustrate using a diagram, so we will use the component given here to illustrate it. Is that clear? So this is just for you all to recall how the standard symbol is used, but this is the answer to the question. Is that clear, student? So this is how current flows through a diode. With that, I'll move on to the next slide. The third part of the question, we have the same diagrams given. There are 3 terminals in component B. Name them. What are the 3 terminals? You all know base, emitter, and collector. Then the fourth question, write one function each for the above components. That is A, B, C and D. A, what is a function? It is a light emitting diode. If it is white light emitting diode, we can use it for lighting of houses, torches, headlights, LED televisions. So for all that, we can use a LED or even as an indicator. So we can write any one function. I can say LED television screen. You can write any other function also. Pointers, LED torches, LED lights, LED headlights, anything can be written. Then B. B is a transistor. How can you use a transistor? It can be used as a switch in electronic circuits. It can be used as a current amplifier, a signal amplifier. It can even be used as an automatic switch with a light sensor. So you can give any of the functions. Now B, transistor, I will say used as a switch in electronic circuits. Used as a switch in electronic circuits. Then C, you can remember students, it is the resistor. So resistor controls the current flow through the circuit. Control the current flow through a circuit. And then D, you can remember, is the diode. Diode, rectifying current, alternate to direct current. Then to protect devices, electronic devices from being damaged due to incorrectly connected terminals. Then diodes, PN junction diodes as solar cells. So you can write any function. I will say rectification of current. Rectification of current. So those are the functions. LED television screens, then transistor used as a switch in electronic circuits. C is the resistor, control the current flow through a circuit, and D is a diode, rectification of current, that is to AC to DC current. Is that clear, students? So with that, I will move on to the next slide. Here I have extra question 20. According to the ability to conduct electricity, materials can be categorized as conductors, semiconductors and insulators. You are familiar with all that. Conductors allow current to flow easily through them, whereas semiconductors, they allow only a small amount of current to flow through them. Materials like silicon and germanium. And insulators, materials that do not allow current to flow through them easily. Shown below is an electrical circuit made by a student using semiconductors. A, B, C and D are components made of semiconductors. So you all know semiconductors like silicon, germanium, they are used to make diodes, transistors. Those are the semiconductor components, electronic components. So here you can look at the circuit. We have discussed similar circuits here. As you look at it, you see the 4 diodes A, B, C and D. Then you know this is a rectification bridge for a full wave rectification process. Here you can see the alternating current source, then the rectification bridge circuit, and then here you can see the galvanometer. And the different points are labeled as A, B, C, D, E, F. Then we have G for galvanometer. So H, I, J, those are the points that are labeled there. So you are familiar with this type of circuit. Then if we take them, name the components A, B, C and D. Now here all the components are diodes. So all of them are the same. Therefore, I will put a bracket like that, A, B, C, D. They are all diodes. Then you don't have to write the name again and again. All of them are diodes. Then the second one. When the alternating current supplied to the input circuit is flowing in the JA direction, name the components that are forward biased out of A, B, C and D. So, if the current is flowing in the direction J to A, this way, then when it comes to point B, you're familiar with this now. When you look at A and D, D will be forward biased. A is going to be reverse biased. Then current comes to point E, flows to point F, to H, then back to point C. When it comes to point C again, you have A and B. Out of A and B, B is going to be forward biased. Then the current comes to point D. Again, C is reverse biased there. So, current flows this way. J to A, B, D, then F, galvanometer H, C, B and J. So there you can see both D and B or B and D. Those are the two diodes that are forward biased. So components that are forward biased, B and D. B and D. Is that clear, students? B and D. With that, I'll move on to the next slide. Then here, when an alternating current is flowing through the input circuit, what will be observed in G? You will see the deflection in the galvanometer in the same direction. But there will be a fluctuation between 0 and a maximum value. So here we can say the indicator deflects in the same direction, fluctuating between 0 and a maximum value. That is what you see there. The direction of the current flow does not change. That is why the indicator deflects in the same direction, but it fluctuates between 0 and a maximum value. You all know the curve. It is like a waveform where the voltage or the current drops to 0. So it fluctuates between 0 and a maximum value. So then, the fourth part of the question. Draw the waves of the electric current flowing through the output circuit when an alternating current is flowing through the input circuit. So we need to show the full wave rectified current. So this is going to be time, that is voltage or current. And here you will get full wave rectified current like that. So it is going to fluctuate between 0 and a maximum value. That is the waveform, full wave rectified current. Is that clear, student? So I am sure you can recall all what we have discussed before. And with that, I'll move on to the next slide. extra question 21. So here also we have a circuit. Now look at this circuit. You can see here it is a transistor. But they haven't shown what type of a transistor that is. But you can see the negative terminal of the battery is connected to the emitter. We have to consider that because A, B, C are the components. Normally, if they don't show the direction, then you all have to understand that the emitter is shown below. And if negative terminal is connected to the emitter, that means it is an NPN transistor. Then here you can see component A is a variable resistor and component B from the symbol. You know it is a resistor, but the arrowheads pointing towards the resistor means it is a light dependent resistor, LDR. So A is a variable resistor, B is an LDR and C is a transistor. So you all can understand that, and the dry cells there. So here from the circuit you can also recall. Now when we have an LDR, here the transistor is going to act as an automatic switch with a light sensor because LDR is a light sensor. You all know when the intensity of light falling on the LDR is less, or if it is dark outside, the resistance of the LDR is high. But when light is incident on the LDR, as the intensity increases, the resistance decreases. So therefore, the transistor can act as an open switch and a closed switch. Is that clear, students? So then, if we answer the questions given to us, part of an electronics circuit with many devices are given below. First one, identify the devices A, B and C. A, variable resistor, B, LDR, or you can say light dependent resistor. So again students, you don't have to write both the names. I am writing both. For that you can recall all the names. You can either say LDR or light dependent resistor. Then C is a transistor. The second one, write the function of the component A. Again variable resistor to control the current flow through the circuit. Control the current flow through the circuit. So then the third part of the question, what is the function of the above circuit? Transistor act as an automatic switch. Transistor functions as an automatic switch. It is on when light is not incident on LDR and is off when light is incident on LDR. So transistor functions as an automatic switch with a light sensor. So that is why it is on when light is not incident on LDR and it is off when light is incident on LDR. That is how the circuit functions. I am sure you all can remember that, students. So with that, I will move on to the next slide. Extra question 22. The diagrams 1 and 2 show two circuits used for half wave and full wave rectification. A bicycle dynamo supplies electricity to A and B. So, if you look at the diagram, students, here you can see in diagram 1 there is only one diode. That means it is half wave rectification. In diagram 2, you can see there is this part, that is the rectifier bridge with 4 diodes, but here they are all LEDs, light emitting diodes. So, you know that is for the full wave rectification. And this part, here again there are 2 diodes. So, you all know the output current has to flow only in one direction. So, these 2 diodes are there to identify that direction. So, this diagram is for the full wave rectification process. That is how you have to identify the circuits. Then, if we look at the questions, what is the type of current produced by bicycle dynamo? Bicycle dynamo produces alternating current. Alternating current. Alternating current. Or you can write it as AC, alternating current. The second one, what do you call the type of rectification done by the circuit 1? Circuit 1, half wave rectifier. Half wave rectification. Then the third one, illustrate using a graph between voltage and current change when the terminals of the diode in the circuit 1 are interchanged. Now, illustrate using a graph between voltage and current change when the terminals of the diode in the circuit 1 are interchanged. The way it is shown now, the positive current will flow through the diode. But if you change the terminals, then what will happen? It will be the negative current that will flow through the diode. Negative half cycles of the alternating current. So, if you are to show it in a graph. So, this is either voltage or current, and that is going to be time. Now, if it was like in this diagram, this way is the positive cycle, positive half cycles of the alternating current. If we change the terminal, it will be the negative half cycles. So, here it's going to be like that. The negative half cycles. They will be allowed through the circuit. So, only that here also the current is flowing in the same direction. They are in the negative direction but only in one direction. So, it has been half wave rectified. I am sure you all can understand that. So, with that, students, I will move on to the next question. This is the last part of the question. Which LEDs in the circuit 2 glow when current flows from B to A? So, when current flows from B to A, here you can see B. It is going to be from B to A. At this point, when it comes, you can see R is forward bias. It will allow current to flow. And then current will come. It cannot go through Q. It has to come to this point. X also will not allow the current to flow this way. So, it is going to be Y that is allowing the current to flow. Then it will come back to point P where you have both here P and S. So, out of P and S, S does not allow current to flow. So, it is P. So, P, R and Y are going to be the forward biased LEDs. So, all three of them will light when current flows from B, then to R, then through Y, then it will go through P to point A. Is that clear? So, the three diodes are P, R and Y. So, here you can see which LEDs in the circuit 2 glow when current flows from B to A. P, R and Y. P, R and Y. Here you can see P, R and Y. Those are the 3 LEDs that are forward biased. Is that okay? Then the 5th one. Sketch the variation of the voltage with time when electricity is supplied by the dynamo to circuit. So there, of course, it is going to be the positive current and it is going to be full wave rectifier. So here voltage, here they have said voltage, so then we can just go with voltage and time, and it is going to be full wave rectifier. Still there is fluctuation, but the current flows in the same direction, full wave rectifier. And then the last part, few parts of the question. 6th one, what should be connected to the circuit to smooth the current obtained here? What do we use to smooth the current? A capacitor. You're familiar with that. A capacitor. Capacitor. And the last question. If the LED given as R is removed, what would be the change in the graph mentioned in part 5 above? Part 5 is this. You have the full wave rectified current. Now out of that, if R is removed, now here you can see, if R is removed, what will happen? So here students, from the bicycle dynamo, it's going to be the alternating current. So what will happen? In one instance, from A to Q, then to Y, then up to this point, S and B. That part is fine. But when current flows from B, then what will happen? The current cannot flow through R. There is no connection there. So because of that, it cannot go back through S also. S is reverse bias. So it will become a half wave rectified current. It will not be full wave rectified. It will be half wave rectified. So that is what we have to show here. If the LED given as R is removed, what would be the change in the graph mentioned in part 5 above? So if you show the change, if you show the change there, time and voltage, you will have half wave rectifier. This becomes half wave rectifier. Because R is not there, half of the negative cycle of the wave, the current will not be rectified. So it will become only half wave rectification. Is that clear, students? So those are the questions in this lesson. Now we have discussed similar questions. You have seen over the different chapters, similar questions have been given to you all, but they are given in different ways. The basic concept is the same, but questions are asked in different ways. So I'm sure you all were all able to answer them correctly. So with that, students, I have completed the lesson electronics. So I'm sure you all have a very good understanding about the lesson.
To watch these important lessons, subscribe to DP Education's YouTube channel right now. Click on the bell icon to stay updated on the latest lessons. Sri Lanka's largest free online school, DP Education.